Hi, my name is Bayla McLean, and we're going to go over transcription. So transcription is divided into three sections: initiation, elongation, and transcription. I like to use the mnemonic TIE just to memorize the steps, not in the correct order, but just like the names. So initiation is the transcription apparatus which locates and assembles on the promoter region and begins synthesis of RNA. Elongation is the RNA polymerase, which unwinds DNA and adds new nucleotides to the 3' end of the RNA strand. And transcription is the end of the transcription unit and the separation of the DNA template strand from the RNA molecule. So RNA is the synthesis of an RNA molecule from a DNA template. Here we have some major players, which are essentially definitions. Now I'm not going to go over all of them. I'm essentially just going to state them out, and then if you would like to go over them later, you can pause. So I have the template strand, the promoter, the terminator, sigma factor, RNA polymerase, and consensus sequence. We also have the -10 consensus sequence, the -35 consensus sequence, RNTPs, +1 site, termination hairpins, hollow enzyme, and coding strand. So we're going to have our transcription map here. And the +1 is going to be your start of transcription. This is going to be the first RNA nucleotide that is transcribed here. Before that, you can have the promoting region, which is going to have the -10 and -35 consensus sequence strands, which are used by the RNA polymerase hollow enzyme to identify where the promoter region is. And the RNA polymerase hollow enzyme is made up of the coenzyme and sigma factor, which is used to identify these regions. The RNA coding region is where RNA is transcribed, and it continues until you reach a terminator. The terminator, I've blown it up right here. It's going to start with inverted repeats, which is this guanine, cysteine rich areas, and it's going to form a hairpin loop, also known as the termination loop. And before that, you're going to see these uracils right here on the RNA strand. It's going to weakly bind to the DNA, which is when the RNA is released from the RNA polymerase and termination occurs. The -10 consensus sequence is deleted. So if this happens, this will lead to RNA polymerase having either extreme difficulty or it just won't find it at all, finding the promoter region, because the -10 consensus sequence is used along with the -35 sequence and sigma factor to identify the promoter region. It's evolutionarily important, and if the RNA polymerase won't find it, no RNA strand will be transcribed, so there won't be any sugar metabolizing enzyme produced. And here's a picture, and you can see the missing strand. And then here's my citations. Thank you.